Hi my friends, today we create this assembly which is destined for placing cork in the bottle. We use here Cardano's hypocycloid mechanical model, where a circle with a diameter half of another circle, it works just like these are moving in a line and this in a line. When we make this to move, to do this I select this component, I find it here, I select angle 12 degrees, I apply drive. You see that now the value of the angle is 12 degrees, and we go to 30 degrees with this arm. We make this 14 times back and forth. Let's see what happens. You see here all the animation. These two axes work on their lines or directions once again, but they seem to be rotated, not translated. Very interesting. These are the components: the body, two ribs, a plate, and many other components, including the cork and the bottle. Let's start. New, standard millimeters IM, place, body. We use again our solution to place this so that it must look. This corner, set current view as home, fit to view. We add the plate, one piece, and the ribs, two pieces. This plate must be aligned with the end, but firstly let me place this on the plate, apply, then flush for this face and this back face. Apply. They have a common plane for the body that plane is this one, and for the plate is this one. You see? Okay. The distance here. Oh, this must be a distance of 10. Let me change something here. Flush of 10. But in the other direction, minus 10. Okay. The ribs constrain this face on this face, apply this bottom face to the plate, apply, and a distance of 57 between these two. 57. Apply. Same for the other rib. This face comes here. Apply. The bottom goes here. Apply. And we apply flush between these two faces. Okay, I want to make something to be more visible, shaded with edges. Good. I collapse everything here to see what we create here. We continue by adding some other components. Active rod is here. Escape space for repeating place. And the other one is vertical rod. They are placed on the axis, as we said, reverted, apply, and this one comes right here inside, with this being down. Okay, apply. Now we place axis on axis, or axis on points. This point, apply, and the other axis, you will see it comes along this line. You see, we place here tangent. This is an important constraint. Then we place the 2 points on this axis. You can see this marvel combination by taking a look here. As you can see, this is the rocking lever, point PA, point PB. The rocking lever is tangent to the the other circle, this circle is double than the other one, or we can say this is half of the other larger one. These are vertical and sloped axes, and from Girolamo Cardano we know that given two circles C1 and C2 and our drawing, where C1 has a double radius as C2, you saw this, when C2 rotates slipless interior tangent to C1, then a point, any point on the C2, describes a diameter or a straight line of the C1. This point is permanently on a diameter of the larger circle. This point is permanently on a diameter of the larger circle. In other words, no matter how we rotate slipless the rocking lever, the points PA and PB move strictly on the vertical and slope axis respectively. Very, very interesting. Now, if we take a look here, we see a gap. Also here, we have to add some bushings. Place bushing 1, bushing 2, but also a buffer. This buffer is made double click of rubber. Why? Because we have to prevent the brutal contact between these two objects. Okay, constrain the axis with axis, but the other solution, apply, and contact between them, because this diameter is the same as the other one. Constrain this point with this point. Apply. Then we can apply insert of this placed right here. Apply. The other bushing goes not with insert. Yes, with insert. Insert this right here, but the other solution aligned. Okay. Now we see that this can be rotated, and this is not okay. So we apply constrain parallel angle, this face with this face to be parallel, and also this face with this face parallel. Okay. We add the rod terminator or termination, and we see a thread here. Double click to see how long it is. It is 20. This is the thread. You see red. Finish sketch, constrain, insert this on this with -20. Good. This assembly also contains 3 ball bearings. They are this. One is here, another here, and another comes right here. To place them in position, we hide this object and we apply insert of this to be here but aligned. Apply. Same for the other one. We make visible this visibility here, and we hide this one because we apply insert of this to be here with alignment. Apply. Again, we make visible what is not visible. Here we also apply insert of this circle on this circle. Apply. Good. We add arm, action arm, this one, and we also insert this to be here. It is okay. If not, we can change the solution. Okay, I rotate this to be somehow in position, and I make tangent this ball bearing with this face. Okay, there are some pins. Place thick pin and thin pin. Thick pin is only one. It goes here with insert, you see, and alignment here. Okay. The other are 3. 1, 2, 3. Place pin, thin pin, 1, 2, 3. We use again insert with the aligned to place one pin, another pin, and the last pin. Okay, we place the handle ball here and also the rivet. Now we constrain axis, this axis, to be coincident with this axis. Apply. Then in contact this face with this face. Apply. And insert for the rivet. It goes no matter what end because it is symmetrical. Okay. Another small piece is the pressure head. The pressure head is threaded inside, so we have to know how deep is this. 15. Constrain, insert, minus 15, this with this. Okay. Now the cork press is finished. We have to add the bottle and the cork. Good, but if you take a look to the original, you see that this is with the wine inside, we suppose, wine. And we have to color, to apply a color to this. Double click and you see here revolution, new solid, full. New solid, this means that inside this is something which must have another color. Properties and red. Okay. Now we see a color inside of this volume. Let's see what is that volume. We discuss about this object. This is the wine and this is the bottle. Okay. Return. We place with insert the bottle on this circle, apply, then the cork along the axis, apply. Now I want to move the cork. I wait here to select the other object and to move it, but I cannot. I make this, yes, and I place it somewhere here, not somewhere here, but in contact with the pressure head. Okay, because we want to place this right in this position. Good. Now you know the procedure. We apply an angle, first solution, 12 degrees between this face and this face. You see how it looks. This is in position. Okay. we select this object to see where is the constraint. 12. We apply drive, we modify this to 30 degrees, and we take a look what happens here, because here we know what happens. Run. Okay, not total moving, but you can change the angle. Let's go back. Take a look here. See? These two are moving on their directions. Okay. Now comes an interesting topic. What I present here is based on the existence of the components that appear in the assembly. Regarding this modeling, you have two options. One, to contemplate what I do and apply my actions by creating your own components of this assembly. And two, try to create the assembly using the actual components you see in the tutorial. If you want to create this assembly independently, you must own the component. That is, they must be yours. As separate creations that I made for the purpose of showing practical aspects in the tutorial, you can download the components only from assets. Access to assets is done by subscribing minimum to the level Journeyman membership. You see here the levels of membership: Core, Journeyman, Patron, Professional. Excepting Core, the other ones include the previous ones. That's all for today. Thanks for watching. Bye.